Today we're going to talk about the new features that PDFtron's PDF3D version 2.22 introduces. Let's jump in. The main changes in 2.22 are new on-page controls for panoramic 3D scenes, CAD mesh subdivision refinement methods, step file format brep tessellation with absolute deviation control, and added new STL export. And there are various improvements in the systems for metadata handling, point cloud coloring, last point cloud format loading, OBJ loader, and many other small corrections. Let's take a closer look at these new features. In this version, there are several new features that support loading and converting of CAD files, transforming those into 3D PDF, STL, and GLTF. In this example, we have a simple conversion of a step CAD file. And if we look at the wireframe, we can see that the tessellation has been default over the whole surface according to specific curvature. In this version, we've added additional processing options to configure this in a more detailed way. One of the options shown here is to use the curvature of solid objects or brep surfaces and refine those into smaller tessellations to more properly preserve that curvature. We can see here the spheres in this ball bearing have been tessellated to a fine degree compared to the other flatter surfaces. This uses parameters of linear deflection, and we've also added an option for absolute deflection so that you can precisely control the amount of tessellation for curves. However, we can see that the flat areas still have coarse tessellation compared to the ball bearings. A new feature added in this release is to allow for further subdivision, where both the curved surfaces and flatter surfaces can have a more uniform tessellation density, not completely related to curvature. This allows for a more uniform mesh, which can then be further processed in things that require a higher quality subdivision. The curvature of breps and the subdivision for planar surfaces are independent parameters and can be controlled according to the model conversions that you're needing to perform. We've been showing here step conversions to 3D PDF. The parameters for controlling this, first of all, have the linear deflection parameter, which can be enabled and set to a value appropriate for your model and the type of curves that you're trying to represent. And those are available in XML control parameters through the PDF3D IO SDK. And then further, the new subdivision system that we've added also has an enable and a separate subdivision tolerance that can be applied for the planar surfaces. The conversion I've just shown in this demo was based on the conversion was made into GLTF and STL. STL is also a very common 3D CAD format type. However, it is very simple and only displays models with a basic single mesh. This can be opened directly in Windows 10 or Windows 11 with the 3D viewer, which comes as standard with the desktop packages. As you can see, the color is lost and it's all a single mesh, but it is very interchangeable. The GLTF version, on the other hand, retains a lot of the mesh structure and the colors and materials. If we open that again with the built-in 3D viewer that comes with Windows, we can see much better shading, materials, and the color has been preserved on the ball bearings in this case. GLTF is a common format supported by many different applications. One of its strengths is the ability to be shown directly within a web browser using a common framework such as 3.js and many others. Here we can just drag and drop the same model that we've just created and shown on our desktop directly here within a web browser using the 3.js default settings. Another use of GLTF is to support 3D presentations. Microsoft PowerPoint and Word now can directly support GLTF as annotations within the documents. Here I've started up PowerPoint, and if you go to Insert 3D Models and then load one directly, I'll insert this same GLTF that we've been looking at, and that now becomes a new annotation which can be floated directly within a slide presentation. And by clicking on the central icon, we can rotate and orient that into any position we'd like. And then saving this presentation, that becomes part of it, and the PowerPoint now has an embedded 3D annotation. To recap, we've seen in this short demo how step 3D CAD models can be converted to 3D PDFs, STL, and GLTF with the tessellation and the resolution of the output mesh controlled in several different ways, including planar tessellation, and shown how the GLTF can be used in many different downstream applications, including 3D documents for Word and PowerPoint. The controls for these are all available as XML tags for the PDF3D I/O system and also the full SDK. Another new feature is STL output and merging of models. Here we have a single model of a brake caliper, and here we have the brake disc that's part of the same overall assembly. These are currently in two separate files defined as CAD 3D models. In a 3D PDF, we can merge these into the same scene and have individual parts shown in relationship to each other. In the new STL output, all of the assembly parts get merged into the same large mesh and then output into a single STL assembly. The XML tags for controlling this are shown here, where we have first the caliper part being imported as one assembly, and then another assembly shows the brake disc. And then finally the output file is set to be a merged STL and set to be a binary type of STL. By applying this, output STL combines both of these into a large mesh which can be reviewed, such as using the built-in Windows 10 3D Viewer application. Any number of assemblies can be merged in the same way. Another new feature is the Panoramic 360 on-page controls. Here at the bottom of this page, we see controls for managing the 3D scene, including going to a home position and then snapping to individual angles, left or right, and playing an automatic rotate to zoom around the scene. In addition, there's some readouts that show the azimuth and the elevation of the particular view at any moment. These controls are completely configurable. In fact, we can show you how they're controlled by the XML tags in the PDF3D.io system. During conversions, tags can be added to introduce interactive controls on the PDF page, such as the interactive push button. In this case, we can see this first push button is defining a home reset, and this calls the reset azimuth angle method, and its position and style are completely configurable. The font and the image overlay that's used to display an icon is set here. The position and size of the button is controlled by the rectangle tags, and the border color can be set to whatever is suitable for the design. A small script section controls the dynamic behavior of each button. Further buttons here can be seen as the left and right control buttons. The display of the angle is shown in a text widget, and many more tags are available to customize the look and feel of the PDF. I really hope that you enjoyed having a look at the updates and features coming in PDF3D version 2.22. This includes products of ReportGen, PV+, PDF3D.io Toolkit, and the full PDF3D SDK Pro. In addition, this covers all the main platforms: Windows, Apple, and Linux. If you do have any comments, questions, or suggestions, please go ahead and post them below or visit pdf3d.com. Thanks so much for watching. Take care.